Good afternoon, everyone. My name is Clayton Baker, and I am a finishing master's student in the Department of Computer Science and Center for Artificial Intelligence Research at the University of Cape Town in South Africa. The title of my talk is An Empirical Investigation for Patterns of Belief Change in Human Reasoning. Now, this is quite a mouthful, so let's unpack each aspect of the title. The first part, an empirical investigation, refers to collecting data to validate or invalidate some research hypothesis or some research question. The next part of the title, for patterns, refer to postulates, rules, or axioms of belief change. So belief change is some theory that we're investigating. And belief change in artificial intelligence can be thought of in terms of two frameworks. The first is that of belief revision, and the second is that of belief update. So when we think of belief change, we think of reasoning. We think of having a set of information from which we make some inference. And when we receive new information, this may mean we need to change our previous inference to accommodate this new information. And to kind of give a metaphor for belief change, I include this picture of a chameleon, where some parts of the day you might see it in one color, blending in with its environment. For example, it's brown. And when it comes out of its environment and it moves into the sunlight, it might choose to reflect a different color. So this is a metaphor for changing beliefs. The next part of the title, in human reasoning, refers to the subject of the investigation to which the theory is applied. So in short, the title means that we are collecting data from human subjects to determine whether these subjects reason in accordance with rules of reasoning for belief change in artificial intelligence. We have two research hypotheses. The first one states that human reasoning is consistent with the Alshuron, Yarden-4, and Mackinson, or AGM postulates of belief revision. The second research hypothesis states that human reasoning is consistent with the Katsuno and Mendelssohn, or KM postulates of belief update. The procedures and methods that we follow come from Creswell 2014's textbook on qualitative, quantitative, and mixed methods research. So these are three forms of empirical research, and they involve the following steps as bulleted on the screen. They involve a description of the data's design, how data is collected, how data is processed, how we as researchers will analyze the data, interpret the data, and validate the data. What is not explicitly mentioned is what data processing entails. We would like to think of data processing as containing two steps: data cleaning and data visualization. The data cleaning step involves converting the raw data received from data collection and converting it into a useful form for data analysis. This means that in our data cleaning step, we strip personal identifiers and anonymize the data. It means we look for missing values. It means we look for duplicate responses and ensure that the format of our data is suitable for analysis, whichever format that may be. The second step, data visualization, is to get a broad picture of what our data looks like, and perhaps we can predict what some of the patterns or trends in our data are. This could be done by visualizing frequency counts of certain variables. It could also be done by creating a box plot of frequency counts and visualizing the influence of different effects on the data before analyzing in detail what those mean. Data analysis and interpretation are the steps in which we discuss our results and how closely they relate to our research question. The last step, data validation, speaks to how reproducible this approach or this research is. Can we say that our results conform to what we expected with our research hypothesis? Are there any gaps? And if there are, we need to be able to address these gaps or mention that there are gaps. So this is the process we follow when we conduct empirical research. In the following 2 slides, we outline our contributions, and there are 5 of them. The first contribution is translating postulates or logic-based reasoning rules of the frameworks of belief revision and belief update into natural language. So these postulates are formulated in some mathematical, logic-based language that computers understand. We aim to translate them into natural language, such as English, which the ordinary human subject may understand. The second contribution is decomposing these postulates into a simpler form. So this simpler form means we take each postulate and we divide it into its premises and its conclusion. So we break it down into 2 smaller parts, each relating to the postulate. And when in step 3, we judge them separately. So we judge the premises and conclusion for each postulate separately. We get a sense of how well the postulate as a whole holds with our human subjects. So the way we do this experiment is through surveys with human reasoners. And in the images on the screen, on the first one, on the bottom left, we show Google Forms as our platform for designing the survey. And on the right, we show Amazon Mechanical Turk, which is a crowdsourcing platform. And this is how we collected our data. It was collected virtually, and all the interaction we have had with our participants is anonymous. So we don't know their names or their personal information. We select some characteristics of our desired sample, and Amazon Mechanical Turk takes care of the rest. So as mentioned, one of the contributions is not judging the postulate as a whole, but judging each component, the premise and conclusion, for plausibility via surveys. Then the fourth contribution is benchmarking these postulates of belief revision and belief update against human reasoning, because the intuition is that if we want AI systems to behave like people, then we need to embed some rules. And these rules were developed theoretically for AI systems, but haven't been tested with human reasoners. In the figure on the screen, we show the example of a scale that we use in our surveys to judge some rule, some postulate for plausibility. This scale ranged from 1 to 10, with the lower end of the scale indicating that a rule was implausible and the upper end indicating that a rule was extremely plausible. Our fifth and final and most important contribution was evaluating whether these postulates, the postulates of belief revision and belief update, hold in human reasoning. To do this, we determine or measure the association between the premises and conclusion of each postulate. In doing this, we compute a 2x2 contingency table, as shown on the bottom right of the screen. There are 4 cells in this contingency table. And for example, if we look at cell A corresponds to the number of participants who judged that both the premises and the conclusion of a rule was true. If we look at cell B represents the number of participants who judged that the premises of the rule was true, but that the conclusion was false. The next step in determining this association is computing a measure called the phi coefficient. This produces a value between 0 and 1, indicating a strong relationship if the value is close to 1, and indicating a weak relationship if the value is close to 0. We give the formula for the phi coefficient on the bottom left of the screen, and it involves using the values in the contingency table, which we show on the right. The next 3 steps are as follows. We test this coefficient measure statistically using chi-square and Fisher's exact test, and we set the significance level at 5%, as is usual in experimental psychology. Then our analysis and discussion is twofold. The first is to determine whether instances of postulates are plausible. So in previous slides, we've indicated that not only do we test the postulates as they are written, but we use examples in natural language to concretize these postulates. So this is what we mean by instances. So these specific examples of postulates, we test if they are plausible. And then we go a step further and we ask, disregarding the examples, are these postulates plausible in general, so that in whichever example we use, these postulates are found plausible? Now, to do this, we used the framework of possibility theory. And this is something that I'm happy to discuss or engage with you about. And you are also welcome to read up on this, because now we're getting into technical territory. On this slide, we show references as used in our presentation. And this brings me to the end of my talk. So I invite you to bring your thoughts and questions along to the School of IT Showcase, where I'll be happy to answer them and engage with you more about my work. Thank you.